Welcome to the ninth screencast in this series on parametrizations. I've now covered all the examples that I intended to cover, and I just want to relatively quickly go over some advice and comments about sketching parametrizations. I'm just going to go over the bullet points that are in the lecture notes. First thing is to look for rotations. So I bold spot rotations. So anytime you see something like an x of t is some b of t cosine, and a y of t is a b of t sine t, then you see that in xy there's a rotation, and the quote radius is this b of t. Of course, it might not just be an x of y, there might be a z component as well. Sometimes you'll have, the more relevant thing is powers, so don't forget to look for powers. Sometimes they'll be obvious, sometimes less so. And by this I mean, we looked at the parabola, but in general, sometimes what you might want to do is essentially eliminate the parameter, even though the whole point of parameterized curves is to have the parameter. Sometimes you might want to eliminate eliminate the parameter, and get, in particular, if you have something like y is equal to x to some power alpha, maybe a fractional power, or could be x is equal to y to some fractional power. That might be the best way to get some handle on the curve and be able to sketch it. You ought to know how to sketch such curves. I'll draw them in red. Such curves for various values of alpha. I'll just draw a few. So alpha equal 1 is like this. Alpha, let's say, is less than 1 but bigger than 0, like this. Alpha is bigger than 1, it's like this. And let's say alpha is negative, like this. And that should be clear that this is x, y, and that's for the case that y is equal to x to the alpha. So I was not discussing this case, I was discussing this case. All right, so you should know how to sketch these such curves. Look for shift of origin, shift of coordinates. That's clear. I won't discuss it further except to say that it's not always obvious that that's what needs to be done, but just keep in mind that you might need to do that. Look for limiting values of t. I haven't really discussed this much. Look at limiting values of t. Particularly, I'm going to use it. What I'm going to do here is I'm going to use this this example, combine it with this example here. Let's suppose in doing that example, I had that b of t. This is kind of common to have something like this. It's 1 over 1 plus t squared, something fairly simple, but different from from the kind of spirals we considered previously. This again is our kind of our radius, our local radius as we do this rotation in x and y. So in order to just understand what this radius looks like, you'd like to graph it, or you don't necessarily have to graph it, but you have to understand it. It's useful to think in terms of a graph. So as a function of t, what does b of t look like? Well, the important things are when t goes to plus or minus infinity. So t goes to plus or minus infinity, b goes to 0. So that's a limiting case. So we know that it goes to 0. Plus or minus infinity is positive. It's positive and goes to 0. And the other interesting case is where t goes to 1, or simply is, 0 simply is equal to 0, and then b is equal to 1/2, which is its maximum value. Again, I'll leave it for you to verify, which means that b of t looks something like this, where this is the value 1/2. And so from that, for example, if you had to graph, if you had to make a sketch, I should say, make a sketch of this curve, what you would have is, let me do an axis. What I would have is the radius is going to be 1/2 when t is 0. So this will be when this t is 0, b is 1/2. Sorry, I'm in 1/2. And then I'm going to wind. I always I'm going to wind in this direction, but the radius is going to decrease, and I'm going to wind that way. So that corresponds to t increasing. The radius decreases. That's what I've drawn here. And I can go the other way. I can go this direction. Corresponding to t going negative, and that will just look the same. It's an example of something I haven't really discussed much, but looking at limiting values of t in any case. And then on the 3D front, what I have in the notes is 3D is challenging. One concrete suggestion that I would make about 3D, apart from looking at these various coordinate planes, well, I guess that's an important thing to say, but hopefully that's been clear, is to, well, let me say it this way. My first comment is to draw the axes first. I just think you're better off trying to draw a sketch after you've put down your axes rather than trying to do it before. So I would say put the axes down first and then try and draw the curve. And maybe before you try and draw the curve, look at particular planes. The way I've been doing, you might want to, let's do something different. Let's look at the YZ plane and see if you can learn anything about the curve, in particular projections first. So that's my advice about sketching. It can be difficult, particularly in 3 dimensions, but with practice, I'm sure you'll get it.